Next we will see what is n-step state transition probability. From the name itself you can think about the meaning. From one state to another state, it will take n steps. Suppose if you want to move from I to j, then you need n step means we can write this as Pij of n, and it is defined as probability of x m plus n is equal to j given, this is given, x m is equal to I. That is, what is the meaning here? In mth step we are in ith state. After n transition, that is m plus n, initially we are in mth step and we are in ith state. After making n transitions, so I am writing m plus n here, we are moving to jth state. So we are moving from ith state to jth state in how many steps? In n steps. So we are calling this as n step transition probability. It is denoted as Pij of n. Next we will see Chapman-Kolmogorov equation. It is a very important 2-mark question. Consider 3 states I, k, j. We have to move from I to j in n steps. That is, we can write it as Pij in n steps. We are moving from I to j in n steps. How we can move? That is, from I to k first we can move. After that we can move from k to j. Suppose we are taking r steps in moving from I to k, then definitely we will take n minus r steps while moving from k to j. So I am writing Pij of n as summation over k Pik of r, because we are taking r steps from I to k, and remaining Pkj in n minus r steps, n minus r. Suppose the same Chapman-Kolmogorov theorem for homogeneous Markov chain. What is meant by homogeneous Markov chain? The chain which does not depend on time unit. Already we have seen this definition in class. The chain which does not depend on time unit, then we can call it as homogeneous Markov chain. In that case, it does not depend upon the time unit. So we can write Pij of n. Okay, this is equal to Pij the whole power n. If you want to find out what is the probability in moving from I to j state in n step, will be equal to the probability you have to multiply n times, because we are considering homogeneous Markov chain. So we are having 2 forms of Chapman-Kolmogorov equation. Is it clear? Next we will see what is a regular matrix. We know very well every Markov chain can be represented in terms of a transition probability matrix. Okay, that matrix is said to be regular if the entries of p power m is positive. If entries of p power m is positive, where m is any positive integer. Where m is any positive integer. Suppose we are representing the TPM of a Markov chain, and if you find out p square or p cube, whatever it may be, And if your probability matrix is positive, that is all the entries are positive numbers, then we can say the given TPM, that is state transition probability matrix, is regular. So we have seen two things, that is Markov process and Markov chain. These two definitions I have given already in our class itself. What is the Markov process? The process which depends on the present state, not on the past. I have given so many examples. That is, we have taken one example, that is the weather condition of today present on the previous day, not on the past. So it is called a Markov process. And when will you say it is a Markov chain? If your state space is discrete. If your state space is discrete, we can call it as it is a Markov chain. And we have seen what are the classifications of Markov chain. I have given one table in our class actually. Classification of Markov chain depending upon the state space and time domain. So we are having 4 types of Markov chain. You please refer our classwork notebook. We are having 4 different types of Markov chain depending upon state space as well as the time domain. Next we have seen actually the non-homogeneous Markov chain. When will we say the Markov chain is non-homogeneous? If the state transition probability depends on the time unit, we can say it is a non-homogeneous Markov chain. If does not depend upon the time unit, we can say it is a homogeneous Markov chain. Homogeneous Markov chain. So these two definitions also we have seen already in our class. And in this video I taught you what are the state transition probability matrix. How to write the state transition probability matrix. Simply we can call it as TPM, transition probability matrix. If a Markov chain is given, how to write the transition probability matrix, right? That is called TPM. And one more thing we have seen, that is n step TPM. Suppose we are taking n step in moving from I state to J state, we can say it is called n step transition probability. Suppose if we are taking only one step in moving from I to J, means we can call it as a single step transition probability matrix. And we have seen what is Chapman-Kolmogorov equation. Chapman-Kolmogorov equation. What is Chapman-Kolmogorov equation? It is a very important topic. That is, if you want to move from I to J step in n transition, then it is possible that we can move from I to K in R step and K to J in n minus R step. So that is called the Chapman-Kolmogorov equation. This is for a non-homogeneous case. Suppose if it is a homogeneous Markov chain, then we can simply say Pij of n is equal to, I have written like this, right? That is Pij of n will be equal to Pij whole power n, because we already know that what is the homogeneous Markov chain. It does not depend upon time unit, right? So it does not depend upon this n. So I am writing Pij of n is nothing but Pij whole to the power n. One more thing we have to remember, what is a regular matrix. When we will say it is a regular matrix, if the TPM if the TPM of some Markov chain is given, and if you are finding what is P square and P cube and so on, in one stage you will get all positive values in this matrix, then we can say it is a regular matrix.